Hi there, welcome to your third lesson on the chi-squared test for independence. In this lesson, we'll move ahead from the other two by using our calculator and interpreting our results when we calculate the chi-squared statistic. It is really essential you watch the other two videos before watching this one. So if you are here without having seen video 1 and 2, watch those first. Okay, the problem we were working at in the last two videos was the question of, is there a choice of racket sport at a certain club? Is that choice independent of gender? In other words, does one gender prefer a certain racket sport or not? Okay, to recap a few things we looked at, there's something called degrees of freedom. Degrees of freedom are calculated by looking at the number of rows and columns in your table of data. When doing this, we ignore the totals columns. We just look at the data before the totals are calculated. So here we have 2 rows, 3 columns. To calculate the degrees of freedom, we always do rows minus 1, so 2 minus 1 is 1, times columns minus 1, which is 3 minus 1, 2. So rows minus 1 times columns minus 1 in this case would be 1 times 2, which is 2 degrees of freedom. Alright, next we talked about what an observed frequency is. So here's our table of actual data of males who enjoy the sports and females who enjoy the sports. And then we can, those are observed frequencies. From that, we were able to find expected frequencies. And the way we did that was to calculate basically a probability. For example, if we're looking at males who like tennis, we just said, what's the probability of somebody being a male first of all, so 33 out of 60, the whole group, and what's the probability of somebody liking tennis? 19 out of 60. We multiply those, so we're figuring out probability of getting a male who likes tennis, and then we multiply that by 60 to get an expected value. So that probability times the 60 people tells us we would expect to see 10.45 males who like tennis, but our actual data is 10. They're pretty close, but the difference is what's key to calculating the chi-squared statistic. So now we have a table of observed values and expected values, and our job is to figure out how far from the expected values are the observed values. If the observed values are very different from the expected ones, then we can conclude that there must be some dependence between gender and their sport preference, because if the differences are much bigger than we expected, then we can say there's something going on here. There's something influencing something else and are giving us observed data that's different than what would be expected. So that's kind of how the chi-squared test works. And we calculate this thing called the chi-squared statistic using this formula. Again, that was in the last video, but basically you're subtracting your observed values from your expected. You're squaring that, you're divided by expected, and then you're doing that for each data point. Okay, it says if this number is larger than a critical value, then we reject the null hypothesis. If it is smaller, we accept. Let's take a look at what that means in more detail now. Okay, when we calculated that value for our data, I did all the subtractions and squaring and all that, and did the sum of all those, the sum, and then we got a value of the chi-squared calculated value was 7.09. So that's, in a way, that's saying on average, each of these points, it's not really on average, it's a square of the average, but a square of the average, okay, on average these points are different from the expected by this value when they are squared. So it's kind of a big number here, but let's take a look at how we use it. By the way, I had you doing this manually before. Well, you used a calculator, but you did value by value and all that, and you did this manually. But on exams, it says here you will be allowed to use your calculator to do this. So let's figure out how to get this value in our calculator now. Let me show you. Grab your calculator and follow along. Okay, so I have mine ready here. Here's the steps you're going to follow. Okay, so the calculator is ready to go. We're going to enter a table of data in what is called our matrix. So you press second, and above the x squared here it says matrix. So I'm going to press that. There's matrix. Just like when we use the stat menu, there's an edit option here. And edit is where you enter stuff into a table. So I'm going to arrow over to edit. And now I want to enter into, you can choose any matrix you want, but let's use matrix A. So I'm going to choose matrix A. and that it lets me choose how big the matrix is. The problem you may see though, however, right here is maybe somebody's already entered something into your matrix. So let me show you now how to clear matrices first, so that you can have a clear matrix ready for it to go. So I'm going to quit here. I'm going to press second and then the plus button, because above that says mem, and that means we're going to do something with the calculator memory. So press that. Then you're going to go to number 2, memory management or delete. And then you'll see number 5 here is matrix. So I'm going to press 5. Alright, I only have one matrix I've started to enter data for, but you might have multiple matrices listed here. Any matrix you want to clear out, and for yours, if there's any here, you can clear them all. So every time your arrow thing is beside a matrix, you're going to press delete and it's going to clear that matrix. So delete, that's gone. Make sure you have all your matrices cleared. I'm going to press second and quit, and then I'm going to go back into matrix. Second, this button for matrix. Again, we need to go to edit to enter our matrix data, and I'm going to enter the data into matrix A, so I'm going to press number 1. Okay, it says 1 by 1. That means 1 row, 1 column. But our matrix has to be 2 rows and 1, 2, 3 columns. Again, you're ignoring the totals. So I need 2 by 3. Okay, now my matrix should be ready. There it is. You can see it has the spots I need, six spots. I'm going to enter our observed data into there. So my on-screen calculator is a little bit slow, so I entered it in there. Make sure you have your data in there. I'm going to show you the next step now. So now that we have our data table in there, we're going to go to our stat button, the one we've always used for statistics. So stat, and now we've always used edit calc, but now we're going to use tests. There are statistical tests here. So I arrowed over to tests, and all the way down the list, since it's near the bottom, I'm going to press up instead, and we're going to come up here, and I can see right here, C is the chi-squared test. Press enter there. And now it has, okay, it's saying where can I find the observed data and expected data. So our observed data I entered into matrix A, so it's already there. Expected, well, you're like, hold on a second, I didn't enter this data in. Well, the good news is the calculator will calculate it for us. So it says expected matrix here being B, but it's basically saying I'm going to calculate it for you, and then I'll throw all these numbers into matrix B. So it's going to do that for us. So all we have to do is put the observed values in A. So now I'm going to go to calculate, press enter, and it gives us our numbers here. So you can see the chi-squared statistics 7.085, which matches what we did when we calculated by hand, value by value. That's great. There's also something called a p-value. We'll talk about it in a moment. And it says degrees of freedom is 2, and we knew that degrees of freedom is 2 for this one. So that's great, good news. So other thing I want to show you is how do you see your expected value table, because maybe you want to get some of those values. So you're going to go to matrix again, so second, this button here, and now here's your matrices. We're not going to go to edit, we just want to go see the matrix. So I'm going to go like this to matrix B, see how it's created it for us. Press enter there, and there I can see the data, and it matches what we had in our expected value table when we calculated in the previous lesson. Alright, so that's it, and let me just get those. Oh no, those numbers will be there again. You'll see the p-value in a moment. But again, just a reminder to clear out the matrix because you might be doing another problem soon. You go here, memory, number 2, memory management, number 5, matrices, and I'm going to press clear there, sorry, delete, and delete again. Now I'm ready for the next problem. Okay, so that is how you use your calculator to do that. Let's talk about some more things. So here's our observed values, expected values. There's our calculated value. Now, we said that in chi-squared testing, we often set a significance level of either 10%, 5%, or 1%. 5% is a very common measure. So it says for a 5% significance level, the critical value is chosen so that the probability of the test statistic being greater than this value, if the two variables are independent, is this. Well, let me explain what that means. Basically, we're saying there's only we want to make sure that there's only a 5% or less chance that this value we calculated is possible if these two things, if sport and gender are independent. Because if sport and gender were not independent, then our values here would be close to the expected values. But if gender actually influences sport choice, then there'll be a big enough difference between these and these that we can say uh, one influences the other. And we're saying we want that chance of the difference we have occurring being only 5% or less. That's what significance level means. All right, so, oh, there's a question there. So will the critical value then be larger or smaller if we chose a 1% significance? All right, so again, our critical value is going to be one that's we're going to compare to this. Basically, we're going to say if there's only a 5% chance of these things being this different, then there's a certain value that our chi-squared statistic will be. And if our calculated one exceeds that value, then we know we've beat that 5% chance of it happening. So what do you think will happen if we have a 1% significance set? Will we have a critical value to compare this one to that will be larger or smaller than this value? Okay, well the answer is it will be larger for sure, because if we're saying now we want to be so certain that our data is different from the expected, that it's only a 1% chance of that happening, then the value we must get showing our difference must be quite large. Okay, so now we are given that critical value. So for 2 degrees of freedom at a 5% significance level, our chi-squared critical value is this. We're going to compare that to ours. Okay, so we're going to use this value and compare to our test statistic and decide if we're going to accept this null hypothesis or reject it. So again, our null hypothesis is that racket game is independent of gender. Okay, so here's our calculated value, and here's the critical value at 5%. So our calculated value, which again shows how different our observed values are from expected values, so we can see that our number is bigger than this one. And if that's bigger than that, we can say, well, it's so big that therefore the two things must be, they cannot be independent. They must be dependent. Gender must influence racket choice, racket sport choice, because we see that our values are so different from the expected values, more than the 5% would allow. All right, so next we also said on the screen we had not just the chi-squared value, but this thing called the p-value. Well, the p-value is just your significance level, right? We just said we are working at a 5% significance here, and it's basically what our p-value means. So let me put it here. We got this p-value of this 2.89%. This was the significance level. So our p-value basically implies that the chance of our difference occurring between our observed and expected values, this value here, which represents our differences, the chance of that happening is only 2.89%. But we said we're okay if we're at least 5% or less. So our percent chance of this occurring is less than what we said is our significance level. So therefore, again, we reject the null hypothesis. All right, so with the critical value, we're trying to find ours exceeding the one we have, but with the p-value, we want our p-value being less than the one we've set. I hope that all makes sense. It's a kind of a tough topic to grasp at first, but I hope through watching these videos it's made sense along the way. So here's a summary. Oh, sorry. So if we reject our null hypothesis, we are accepting the alternate hypothesis, saying gender, a racket game choice depends on gender. Okay, so here's a summary of that. Please pause the video and kind of read through this. This is important. And now let's try a problem. We have a problem here. We have given this table, given this information. We're looking for a 1% significance level. Therefore, it's a high critical value here. See if you can answer some of these questions. Okay, so you could have used your calculator for all of that. Please check all your answers here. It's really important. Basically, this is the kind of question you'll see on tests and exams now, and the kind of skill you should have from these 3 videos. So make sure you check all that work there. Okay, let's do one more. We have American Bulldogs. We have the data given here. Please read this question right now. Now we're going to take this data and do something very different. So we're going to find the mean of 50 dogs. So you're going to enter all the weights into a stat edit and then table, put all the weights in, and then do a stat calc and figure out the mean. Okay, there's the answer. There's some more questions and answers there. So you're going to enter this data table in here. You're going to check these answers. Let's see how you did.